Hello. So now we are going to discuss transactional databases, how the transaction happens on database systems, on demand, and distributed systems. What are the different type of on demand computing are there, distributed computing are there. So the first thing that we learn in this is Cap's theorem. What is Cap's theorem? It is one of the most important theory in database modern databases management system. How it is important, like who invented it? Bruce has invented it, and what it proposed? It proposed this theory. It is impossible for distributed computer system to simultaneously provide following three together with guarantee in single instance. What does it says? It says that in distributed computing, it is very hard uh, to guarantee all the three properties, that is consistency, availability, and partitioning, all the together at a single time point or single instance. Means at a single instance or at a given time point, it is very hard to guarantee all the three properties together. Consistency, what does it mean? All nodes should view the same data at the same point. What does it mean? There should be proper consistency. Means there could be tens of friends aligned to our account in Facebook. So they can see same post, means there has to be same text. So this is consistency in the text of the post. Then availability. It means that guarantee that every requested user will receive the response or they will get a failure. So availability means they have to get the successful feed or that post that we are saying, and it is very hard to guarantee every time on current internet world that every request will have the same response, and they will have the what they will see it according to either with the consistency or with the partitioning. What is partitioning? Partitioning means how the system continues to maintain its failure or losses in the multiple nodes, means replication of the data. So what does partitioning means? There are, suppose, three or four servers in India: Hyderabad, Bangalore, Mumbai, and Delhi. So what they do, they keep on replicating and keeping three copies of the same data. So suppose if some server at Bangalore goes down, so the three other servers would have uh, at least two copy, means Mumbai and Delhi would have two copies of data. So it will have partitioning proper, and it will maintain the loss and failure of one node at Hyderabad. So this is how it means partitioning. So what does Bruce algorithm Cap's theorem says? It is very hard or very difficult to guarantee consistency, availability, and partitioning all together at single instance or single point of time. Means, what does this mean? This means you'll have two things easily guaranteed. You'll get either consistency and availability together, but partitioning not be there. You'll get consistency and partitioning both together, and availability might not be there. You may get availability and partitioning together, but consistency might not be there. What does this mean? We cannot achieve consistency, availability, and partitioning all together. We can achieve consistency, availability, and partitioning all together, but we cannot guarantee it that we will always have consistency, availability, and partitioning all together. Means we can have consistency, availability, and partitioning together. It's what we had studied in asset property. So in asset property, that atomicity, consistency, integrity, and durability. You'll get all the three things: consistency, availability, and partitioning, all the three things together. But in modern day database systems, like in Facebook posts are there, you'll see some friends post, but there are other friends attached to, you won't able to see that post. That is, it is not having consistency. But it is definitely when you'll go to, when someone will go to the account of that person, they'll able to see that post in his wall. So that's what availability means. And they will have proper replication, means San Francisco, Hyderabad would have the proper data management, so replication would be there. So there will be never a failure that your post will be missed out anywhere in the future. So this is what it means. So this Facebook post that you'll see, the Twitter tweets that you see, that LinkedIn post that you'll see. So all these feeds are actually based upon CAPS theorem. That's why you'll see different post or different news or different feeds whenever you fresh every time. So whenever you fresh every time, you'll get new feeds. It is may possible that some of your other friend, which is friend of others, would not be able to see the same post when they could have the rights or permission to see that post, but they are not able to see because it is random. It is based upon caps theorem. Why it is so, we'll see next. So it is based upon NoSQL. What is NoSQL? Not only SQL means, what does it mean? In the modern database system, what happens, work happens other than tabular relational, and which is not the part of older relational database system. So in the older relational database system, there are tabular relations are there, which is having a fixed set of rules to follow and fixed SQL query language to follow. So they have many restrictions to follow. That's why they are being set as SQL. So no SQL system means they may not support the SQL, or they may support some queries of SQL. So no SQL system can also support some query of SQL, like select it would support, update it would support, but not necessarily delete or view like this type of query. So it is not necessary that all queries are being there in NoSQL. So NoSQL database system has different data structure. So like what? They could be different from relational database, means tabular database is not necessarily be there with NoSQL. Like key value players are there, like graphs are there, like documents are there. So NoSQL database system would have different type of data structure for storage purpose. Means in the file system, you would able to read the text file, parse it, and do the processing business logic, and then send the result. That is a kind of NoSQL that you are doing. What you are doing, you are reading simply a text file from parsing, and then after parsing, using some tokens for doing the business logic processing. What does this mean? This means you are doing NoSQL and you are sending it to the some other user as output, and this is output of the query that you had written. Means for every query that you are want to do with that text file in the file system, you are writing your own code to do the processing. So that is power of NoSQL, and it is highly usable for the big data and real-time web application. That's why HDFS would have text file, raw text file broken up into 64 MB chunk size, and you keep on processing those with the help of MapReduce libraries of Hadoop. This is how the highly scalable big data and real-time analytics web application works. So, like for example, in Storm that we had seen, real tweets are coming, and you do the uh, spout bolt and topology for processing at real time. Then mostly NoSQL database systems follow CAPS theorem. So mostly it is not necessarily fixed. So what is there in NoSQL and CAPS theorem is a kind of database management tools or theory or concept, but they are not fixed. So NoSQL is like you are dealing randomly at your own will. You are writing your own code. You are writing your own queries. You are writing your own front end. You are writing your own back end and doing the coding by yourself, not relying on the fixed Oracle database management system or fix some database management system. You are using Hadoop distributed file system. On that file system, you are writing your own queries with MapReduce and all this coding. So this is that most NoSQL database system follows CAPS theorem, but it is not necessary. So some of the NoSQL system may follow asset property, and that in that asset property CAPS theorem may not be true. So what happens? Huddle with no SQL system means what is are the problem you cannot move to the new no SQL system. Like you had already written some codes and your clients are already working with SQL system. So what happens? It is required for you to create a new query or new programming coding for the NoSQL so that you can shift from SQL to NoSQL. What does it mean? You need to write more codes, more programming, low level query languages. You need to write means you have to do the hard code programming by yourself. Then lack of a standard interface are there with NoSQL. So NoSQL would be randomized some of the way. So there is no standard fixed interface system. Then earlier what you have done, you had already invested on some SQL systems and huge investments were there. Then what happens? Some NoSQL systems do not provide all four asset property together. What does it mean? Atomicity, consistency, isolation, and durability are not being provided by some of the NoSQL system. That's what we had discussed initially. Because these NoSQL systems would follow CAPS theorem. So there is a suppose a set or superset where you'll have NoSQL and some were SQL, some follow ACID, some follow CAPS theorem. So there's a huge Venn diagram and complicated Venn diagram would be there. So ultimately these are concepts like asset property is a concept of fundamental database SQL based systems, and CAPS theorem is a fundamental concept of a NoSQL system. Then various type of key value pair graph and document based databases are also having the theories, their own theories for NoSQL system. So I'm just introducing to you that there are two theories: CAPS theorem theory, which says you cannot guarantee consistency, availability, and partitioning all together at a single instance. So means you can have these things, three things together, but not every time. And in that condition, it has been said as CAPS theorem. And NoSQL we discussed, which is different from fundamental databases, relational databases that are known for SQL queries. So, what are the categories of NoSQL database systems? So, there might be other categories as well, but these are the important categories. For example, column oriented. So, it has been older SQL based systems are there, and they also have relational database. But here, the columns are more important, means comma separated, you can say. So, this comma separation is more important as compared to the relational fixed relational database. So What are the example? Cassandra is an example famous. HBase is an example. Hadoop. So then document oriented, what are the document oriented NoSQL database systems? Are like Apache Cows DB, like MongoDB, famous one, OrientDB. So these are document oriented. So what does they say? That there's a document that you have, and you can start reading from them and putting it with some JSON or some XML, and you can have processing. Then you will have key value pair. Means there is a key, and according to that, there could be multiple values of that. So this is key value pairs are their type of database. For example, the famous one is a React, Dynamo, Memcache DB, so Orient DB. So these are having various properties. Like graph oriented database are there, like Neo4j is famous one, like Orient DB, and these are the examples. You can go and read about them if you wish. Then multiple models are there, means combination of column or document or key or graph together. For example, Alchemy database, Cortex database, Orient database. So these are the examples and categories of NoSQL database. Then on-demand computing. What does on-demand computing? Whenever you need it, whenever a client need it, then only it will provide the on-demand computing. How it provides? It provides basically with the help of modern day cloud computing infrastructure, enterprise level computing models are there. So there are various new features that had came up, like in Amazon, like in case of Eucalyptus, like in case of some Google App Engine. You'll have fixed set of CPU cycles that you have to purchase, fixed size of bandwidth that you need to purchase. Then there is fixed amount of some storage that you need to purchase, platform computing environment you need to purchase. So it is one of the feature of cloud computing, on-demand computing, and it is enterprise level model. Means an enterprise like Google, Amazon, or Heroku, they offer some features, and you need to purchase those features like Google Docs, like Google uh, Gmailing system. So all these things your organization would purchase it, and these technologies and computing resources are allocated to the organization or its individual users on the basis of demands. So there are various technologies and computing resources that your organization is going to purchase, or you as an individual going to purchase. For example, storage you had purchased. So as an individual user, so based upon on demand. This is also a concept. On demand videos you have heard about. So whatever video that you need or demand, it will be requested. Then examples of computing resources. For example, CPU cycles are being sold out, bandwidth or availability are being sold out, storage and applications are being sold out. Then ODC is needed for that. Means bandwidth heavy applications are there to work out. Then big data computing are there. Then collect the big data systems are there to how to collect the big data. So these are basically the types of on demand computing that are needed, and you need some heavy bandwidth application. So for these things you go for on demand computing, big data computing, collection of big data, because you have limited resources at laptop or at the machine that you can purchase. After that you can sold those laptop or machines easily. But if you had gone for on demand computing, then it will be easier for you to use for 1 month or 1 year. Then thereafter you will stop paying money to the company, and you'll be out of that uh, charge. So you'll have cost effective way to deal in case of on demand computing. So it is also referred as utility computing that we are discussing since a lot, that and there these concepts are inside the cloud computing. Now the name modification keeps on going, that i- old times there's distributed computing, now after that grid computing, then utility computing, nowadays it is known as cloud computing. So cloud computing follows pay as you go model, high performance computing, and infinite illusion resource. So these are the three such concept that it follows in on demand computing. In cloud computing, pay as you go, high performance computing, and illusion for there is infinite resource. Whichever number of user you have, you ask Google will provide you infrastructure, and Google will charge you if you have too many users and clicks on your own website or some Google web engine application. So this is how the on demand computing works. Then most fundamental will conclude with here, that whatever we had discussed, or so this all falls under distributed computing, because it is mother of every high performance computing, or you can say cloud computing, utility computing, grid computing, whatever you say, it is part of distributed computing. What it deals with, distributed systems. What is distributed system? Like Hadoop distributed file system, like Google file system. These all are distributed file system. Like Storm is a distributed computing, Spark is a distributed computing. So they compute at multiple machines. So the machines are distributed. So this is fundamental field, evergreen field that you can say. Then software systems have different components that are located at different, you can say, different rooms, different cities, or different institutes. So these components or machines interact with each other, and they coordinate with each other through message passing and networking, and they start behaving like a giant distributed computing environment. What are the new names of that? Grid computing, utility computing, cloud computing. These are the branch of distributed computing. Then fundamentally what happens? Whatever be there, grid computing, utility, or cloud computing. So there's only one fundamental behind all these things. That is remote procedure call. Means you have a machine residing on Hyderabad or Bangalore or San Francisco, or in next to your room. Next, it means you have another machine in your same room. Whatever be there, means you are calling remote machine. You need some procedure to call out, and that is said to be remote procedure call. This is the most fundamental name since last 1980s or 70s it is going on. And nowadays what happens, it has been named as operations in web services. So these are different names that anybody can give, but operation is a very famous name in web services of that remote procedure calls. Then you have message passing, means anyhow, if you have you are calling someone and you need a communication, you will send a message. So in case of remote procedure calls, you'll have a message queuing, you pass it over the network and it will go as a packet, and it will hide the location, means wherever it is. If you are able to connect it as an IP and you'll have a network to reach out it, so location transparency would be there, means it will be say that you'll only need some time to reach over there if it is a distance. So that location transparency would be there. You'll need a IP address and all the details of that remote machine to do this remote procedure calls. So in this part we had gone through these references. So I hope that you may go to these links if you want. to go in detail. And thanks. And what we'll do, we'll quickly scan through what we had discussed in this slide. In this slide, we have seen requirements of cloud computing, why changing requirement and changing roles are being there. Architecture, two architecture we discussed, vertical scale up and horizontal scale out. Then concept of reference model of NIST cloud computing references are there. These are the various stacks and how they are communicating with each other. We had discussed this. So there are five different characteristics of, and there are five different uh, five different actors in cloud computing. Then there's cloud consumer, cloud broker is there, cloud providers are there. So these are the various uh, scenarios that we had discussed: scenario one, scenario two, scenario three. Then cloud consumer we had discussed in detail. Then we had discussed cloud SaaS consumer, PaaS consumer, how they are built, IaaS consumer, cloud provider, five different types of activities by cloud provider. Cloud auditor we discussed, cloud broker we discussed, cloud carrier we discussed. What are the scopes of provider and consumer we discussed. Then various kinds of cloud computing architecture we discussed, like Web 2.0, mashup we discussed of web services, RSS feeds we discussed, Hadoop we had discussed, how it is fault tolerant, MapReduce we discussed, distributed file system architecture we discussed, name and secondary node SDFS force we discussed, SDFS name node data node we discussed, SDFS data replication we discussed, MapReduce we had discussed, word count example we had seen, then Storm as a real-time analytics platform we had discussed, which is equivalent to batch processing of MapReduce. We discussed about topologies, how the graphs are being created from the streams of data, how the spout and bolt are being connected in the Storm-based coding. We discussed about how Google file system being invented by Larry Page and Sergey Brin, which is older named as Big Files. Then what how Google content management takes place so that it is so fast. This is the architecture we had seen. Then Hadoop inside the Google Cloud Platform. We discussed about how web application could be deployed on Google App Engine. So this is the architecture that we had discussed. Then Google Web Toolkit, we discussed that how we can write codes on our own laptop or machines and deploy it over Google Web Engine. Then Eucalyptus has various cloud level platform, cluster level and node level things are there. Then various nodes are there which is having different VM virtual machines. They have the different cluster controller, storage controllers there, and VM brokers there, and they have the different levels of controlling, like cloud controller controls cluster. So there's API connectivity we discussed, publicly available Ruby on Rails we discussed that uses model view controller, how it sends to dispatcher, then controller, then action views show the files, and in middle of that, active records will process the code of database and controller do the processing. So this is based upon RESTful architecture we discussed. Then we discussed in detail what is model, what is view, and what is controller in Ruby on Rails. Then grid, OSOA, and cloud computing, we had seen common architecture. We had discussed about URL versus URI. We discussed about web services invocation, how it client stuff and server stuff works, how this client and server communicates using WSDL like interface, how the web service invocation works, how older grid computing actually works with fabric layer, connectivity layer, resource layer, collective layers, application layer. Nowadays, in cloud architecture, they are being said as fabric layer, unified resource layer, platform layers, application layers. And this is the comparative stack that we had discussed of grid and cloud architecture. Then today we had discussed about CAPS theorem, Bruce algorithm, consistency, availability, partitioning are not met at the same instance. It's hard to meet out. And NoSQL we discussed it's different from SQL systems, and majorly NoSQL system follows CAPS theorem, and NoSQL system do not provides all four properties of ACID, that is atomicity, consistency, isolation, durability, is not there with NoSQL system. We discussed about different categories of NoSQL system: column oriented, document oriented, key value, graph, multimodal. Then we discussed about on-demand computing, that whatever been required, CPU or bandwidth or storage or some resources or application are required. So you can use the on-demand computing, which is a feature of cloud computing. And earlier it has been known as utility computing. So all these things are merged, started saying as cloud computing. Then we have seen these all are being generated from distributed computing, whether it's grid, utility, or cloud computing. And what is the most fundamental concept behind this distributed computing? Remote procedure call, message queuing, that there is message passing through packets, and location transparency. You should know the IP address and all the information of remote machine. So these are the references, and thanks all of you for this session. And here we concluded with second part of cloud computing. Any doubt or any query? Okay, so we'll meet in next class.